In this lecture, we are going to talk about the anagram problem. So first of all, what is an anagram? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So the original word or phrase is called the subject, and any word or phrase that exactly reproduces the letters in another order is called an anagram. So for example, we have the word restful. In this case, this is the subject, so the original word or phrase. And we can make sure that fluster is an anagram of restful because we are going to reuse all the letters of the word restful in a different order. So all the letters present in the word fluster is present in the word restful, and this is called anagram. So this is what we are going to implement.
So let's implement the problem itself. So first of all, we have to create a function is anagram. Of course, we will get two strings, string 1 and string 2. Of course, we know that if the length of the strings differ, it means that they are not anagrams. So this is why we have to check that if the length of string 1 is not equals to the length of string 2, so the number of letters are not the same for the two strings, then of course we have to return false, which means that string 1 and string 2 are not anagrams of each other. Okay, and else what do we have to do? We have to sort the letters of the strings, and then we have to compare the letters with the same indices. Okay, so string 1 is equals to the sorted function as far as string 1 is concerned. So we are going to get a list data structure out of letters, something like this, and with the help of the sorted function, these letters are going to be sorted in the list data structure. So this is what we are going to do with string 2 is equals to the sorted as far as string 2 is concerned. Of course, this is the bottleneck because it has ordo n log n running time complexity, which means that checking the anagram cannot be faster than ordo n log n. Of course, n is the length of the given strings. Okay, and after that we have to check the letters with the same index, with the same indices. So what do we have to do? For I in range the length of string 1 or string 2, it doesn't matter, because after checking the length, we know for certain that both of the strings contain the same number of letters. So what do we have to do? If string 1 as far as index I is concerned is not the same as string 2 as far as index I is concerned, then we have to return false, which means that they are not anagrams. And otherwise, if we have checked all the letters one by one and they are matching, it means that we have found an anagram. Okay, so let's take a look that if the name is equals to the main, so basically we create the main function, we have string 1 is equals to a list, for example, fluster, so F, then L, then U, then S, T, E, and R. So we have fluster, and we are going to define the second string as far as restful is concerned. So we have R, E, then S, then T, then F, then U, and L. So we have restful and fluster, and we can check that is anagram as far as S1 and S2 is concerned. So let's run the algorithm, and of course it is going to return true, because if we print out the strings after the sorting operation, so we print out string 1 and we print out string 2 and run the application, then as you can see, both of the list data structures containing the same letters associated with a given index. So as you can see, there are the same letters right below and right above each other. If we have, for example, fluster and rest full, for example with E, then of course it is not going to be an anagram because the letters are not matching, as you can see. So this is how we can check whether two strings form an anagram or not. Of course, the running time complexity is ordo n log n because this operation has ordo n running time. So after that, we can come to the conclusion that the overall running time is ordo n log n plus ordo n, which is equals to ordo n log n. So it has a linear rhythmic running time complexity as far as the number of letters are concerned in the underlying strings. So this is how we can check anagrams. Thanks for watching.